In this video, we're going to focus on balancing redox reactions in acidic solution. So let's start with an example. Let's say if we have the reaction between zinc and the chlorate ion, and let's say that it produces the zinc plus 2 cation and chloride. So what do you think should be the first thing that we should do in order to balance this reaction under acidic conditions? So we need to separate this reaction into half reactions. Let's write a half reaction between zinc and zinc 2+. Now, when balancing a half reaction, balance the atoms first, and then after that, balance the charges. So we have one zinc particle on both sides, but the charges are imbalanced. On the left side, the total charge is 0, but on the right side, the total charge is 2. So these two numbers differ by 2, so we need to add 2 electrons. Always add the electrons to the side with the higher charge. In this case, the right side. By the way, what kind of reaction do we have here? This half reaction, is it oxidation or reduction? Whenever the electrons are on the right side, it's an oxidation half reaction. Zinc is releasing or giving away electrons. Another way you can look at it is by analyzing the oxidation number. Whenever the oxidation number goes up as you travel from the left side to the right side of the reaction, it's oxidation. The zinc is being oxidized in this reaction. If the oxidation number decreased, it's reduction. Now let's move on to the next half reaction. So we have chlorate on the left side and chloride on the right side. Now before we can balance the charges, we need to balance the atoms. We have one chlorine atom on both sides, and we have 3 oxygen atoms on the left side. So we need to add 3 oxygen atoms to the right side. Under acidic conditions, you can balance such reactions by adding H plus or H2O. Since we need 3 oxygen atoms on the right side, let's add 3 water molecules, since water contains oxygen. So now the oxygen atoms are balanced. Let's move on to hydrogen. Notice that we have 6 hydrogen atoms on the right side. So we need to put a 6 on the left side. We need to add 6 H plus to that side. So now all of the atoms are balanced on both sides of the reaction. Now we can balance the charges. What is the total charge on the left side? On the left side, we have 6 H plus ions. So it's 6 times 1. So we have plus 6 from those ions, and we have a negative 1 charge from the chlorate. So the total charge on the left side is positive 5. On the right side, we only have a chloride ion, so it's negative 1 on the right side. What is the difference between 5 and negative 1? 5 minus negative 1 is 6. On a number line, they're 6 units apart. So we need to add 6 electrons, but to the side with the higher charge. Since the left side has a higher charge, let's add it to the left side. Notice that for the other reaction, the electrons are on the right side. So for this one, they have to be on the left. They have to be on different sides of the reaction. They can't be on the same side, because one of the half reactions has to be oxidation and the other has to be reduction. So whenever the electrons are on the right side, it's oxidation. If they're on the left side, it's reduction. Now the next thing that we need to do is we need to make sure that both of the electrons on each reaction are equal. So we need to multiply the first half reaction by 3 so that we can get 6 electrons. So it's going to be 3 zinc atoms plus, or this is going to turn into 3 zinc plus 2 ions, and 6 electrons. Now, the other half reaction, we don't really need to change anything. But I'm going to rewrite it though. Let's get rid of that one. So in the other half reaction, we had 6 electrons, a chlorate ion, 6 H plus ions, and on the right side, it was chloride and 3 water molecules. Now that we have the same electrons, we can add the 2 half reactions. When you add them, the electrons will cancel since they're on opposite sides of the reaction. And then everything else, you could just bring it down. So to the left of the arrow, we have zinc, chlorate, and the H plus ions. And on the right side, we have the zinc ions, chloride, and water. So this reaction is balanced, and you can check it. We have 3 zinc atoms on both sides, 6 hydrogen atoms, 3 oxygen atoms, and 1 chlorine atom. Now the charges must balance as well. Notice that the total charge on the left side is 6 plus -1, which is 5. And here it's 3 times 2, which is 6, plus -1, and it's 5. Now let's try another example. Consider the reaction between iron metal and the permanganate ion. Go ahead and balance this reaction under acidic conditions, using what you know at this point. So just like before, let's separate it into half reactions. So let's start with iron metal. In this reaction, we have 1 Fe atom on both sides. So the number of Fe particles is the same. Now we can balance the charges. The charge on the left is 0. On the right, it's 3. These two numbers differ by 3, so we need to add 3 electrons to the side with the higher charge. So that's it for the first one. Now let's move on to the next half reaction. So we have permanganate, and it's turning into Mn plus 2. So the manganese atoms are balanced in this reaction. We need 4 oxygen atoms, so let's add 4 water molecules to the right side. Now that we have 8 hydrogen atoms, we got to add 8 H plus ions to the left side. So now that's balanced. Now we need to consider the charges. The total charge on the right side is 2. On the left, it's 8 plus -1, which is positive 7. 7 minus 2 is 5. So we need to add 5 electrons to the left side. So now the second half reaction is balanced. Now we need to make the number of electrons equal. We have 3 in the first half reaction, 5 in the second. So the least common multiple of 3 and 5 is 15. So therefore, we need to multiply the first reaction by 5 to get to 15 electrons, and the second one by 3 to get to 15. So if we multiply the first half reaction by 5, it's going to be 5 Fe and 5 Fe plus 3 and 15 electrons. Now for the second one, if we multiply everything by 3, we're going to have 15 electrons. 8 times 3 is 24, so 24 H plus ions, 3 permanganate ions, 3 of these as well, and then 4 times 3 is 12, so we need 12 H2O molecules. So now we need to add these two reactions. As we add the two reactions, the only thing that we can cancel are the 15 electrons. Now these three, we need to add them to the left side of the reaction as we add the two reactions. So it's going to be 5 Fe plus 24H plus 3 permanganate ions. And on the right side, we have these three. So it's going to be 5 Fe plus 3 on the right side, and 3 manganese ions, and 12 water molecules. So this is the balanced reaction. And to check everything, notice that we have 5 Fe atoms on both sides. We have 24 hydrogens. 12 times 2 is 24. We have 3 manganese atoms and 12 oxygen atoms on both sides. So now the last thing that we need to check is the total charge. We need to make sure it's the same on both sides. So on the left side, we have a charge of 24 and -3, which adds to 21. 5 times 3 is 15. 3 times 2 is 6. 15 plus 6 is 21. The total charge is 21 on both sides. So the reaction is balanced. Let's try another example. Try this one. Iodide reacts with the perbromate ion under acidic conditions to produce iodine and bromide. So let's start with the iodine ion. Now the first thing we got to do is balance the atoms. We have 2 iodine atoms on the right and 1 on the left, so let's put a 2 on the left side. Now let's balance the charges. The total charge of a pure element is 0. On the left side, it's 2 times -1, so we have a total charge of -2 on the left side. -2 and 0 differs by 2, which means we need to add 2 electrons to the side with the higher charge. 0 is greater than -2 on the number line, so let's add it to the right side. Now the next thing we need to do is balance the other half reaction. Now we can do so by adding H plus or water. So notice that we have 1 bromine atom on both sides, but we have 4 oxygen atoms on the left. So that means we need to add 4 water molecules to the right side. So that's it for oxygen. Now let's move on to hydrogen. 4 times 2 is 8. So we need to add 8 H plus ions to the left side. Now let's check for the total charge. The total charge on the right side is -1. On the left side, it's 8 plus -1, which is +7. 7 differs from -1 by 8. 7 minus -1 is the same as 7 plus 1, which is 8. So we need to add 8 electrons to the left side. Now the next thing we need to do is make sure the electrons are equal in both half reactions. So we need to multiply the first one by 4. We don't need to change the second one, which is good. By the way, which half reaction is the oxidation half reaction, and which one is the reduction half reaction? The first one is oxidation because the electrons are on the right side. The second one is reduction because the electrons are on the left side. That's how you can quickly tell which one is which. So now, let's multiply the first half reaction by 4. So we're going to have 8 iodide ions, 4 I2 molecules, and 8 electrons. So let's add these two half reactions. So as always, the electrons will cancel. So everything else, we just simply need to bring it down. So on the left side, we have these three. Now for the right side, we have everything to the right of the arrows except the 8 electrons. So we have 4 I2 molecules, a bromide ion, and 4 water molecules. So this is the balanced reaction. As you can see, we have 8 hydrogen atoms on both sides, 1 bromine atom, and 4 oxygen atoms, and 8 iodine atoms. Now let's check the total charge. The total charge on the right side is -1. On the left side, +8 and -8 cancels, so we just left with this number. So on both sides, the total charge is -1. So this reaction is balanced. So here's the last example for this video. Let's say if you have the reaction between Pb and PbO2, and under acidic conditions it turns into the Pb+2 ion. How would you balance this reaction? So let's start with the first half reaction, which is Pb turning into the Pb2+ ion. The total charge on the left side is 0, on the right side is 2, so we have to add 2 electrons to the right side, since it has a higher charge. So now let's move on to the next half reaction, PbO2. That's going to turn to Pb+2 as well. Both of these two substances, they're going to converge into the same ion. Now, before we can balance the charges, we need to balance the atoms. So we have 2 oxygen atoms on the left. That means we need to add 2 water molecules to the right side. So now that we have 4 hydrogen atoms on the right side, so let's add 4 hydrogens to the left to make it equal. Now the last thing we need to do for this half reaction is that we need to balance the charges. The total charge on the right side is +2, and on the left side it's +4. So these two numbers differ by 2, so we only need to add 2 electrons to the left side, since the left side has a higher charge. Now, because the half reactions have the same number of electrons, we don't need to modify it. So we can simply add the 2 equations. So these will cancel. On the left side, we have Pb, PbO2, and H+. So it's going to be lead metal reacting with lead dioxide plus 4H+. You can call this lead 2 oxide. I mean, not lead 2 oxide. I take that back. Lead 4 oxide. Since the charge on Pb in this particular compound is +4. Now on the right side, we have 2 Pb+2 ions. And we have 2 water molecules. So this is the final answer for this reaction. So we can see that we have 2 lead atoms on both sides of the reaction. We have 4 hydrogen atoms, 2 oxygen atoms, and that's about it. The total charge on the left side is 4, and on the right side is 4. So everything is equal for this reaction. So that's it for this video. Now you know how to balance redox reactions under acidic conditions.